A 700 watt electric heater is used to heat 1 kilogram of water without energy losses. The specific heat capacity of water is 4.2 kilojoules per kilogram Kelvin. What is the time taken to heat the water from 25 degrees Celsius to 95 degrees Celsius? Okay, so seems like we have a lot of information here, so we'll just begin by writing down what we have. We know that the mass of water is provided, so I'll write that mass of water is equal to 1 kg. Okay. We also know that the specific heat capacity of water is equal to 4.2. Okay. What else do I know? Well, I know that the initial temperature is provided. Okay, initial temperature. Now take note, this initial temperature is in Celsius. But if you look at your units, remember we want this to be consistent. kg, we need it to be in Kelvin. And so to change Celsius to Kelvin, we add 273. So your initial temperature is really 298 Kelvin. Okay. Your final temperature is provided to be 95. Again, we change that to Kelvin. So we add 273. That should give me 368 Kelvin. Okay. So now that we've converted it to Kelvin, we can find the temperature difference. Okay, remember in specific heat capacity, if you recall, the formula is Q equals MC change in temperature. So if you want to find the change in temperature of the system, then that's going to be, so I'll just say temperature difference. That is just equal to 368, the final, minus the initial, which will give me 70 Kelvin. Okay, for the temperature difference. Alright, so I have information about mass, I have information about my specific heat capacity. I know my temperature difference. Can I solve for Q? Okay, sure, why not? So let me do that. So that's going to be Q equals 1 kg multiplied by 4.2 multiplied by 70, which is my temperature difference. Okay, if you calculate this, you should get 294 kilojoules. Okay. But if I want to express this into joules, just remember that 1 kilojoule is equal to 1,000 joules. So this is also equivalent to 294,000 joules. Okay. So how is this useful at this point? Well, we know what Q is. The question is asking us to find time. Okay, so if you do not yet know this, take note that heat is actually equal to power multiplied by time. Okay, that is an essential relationship you would need to know. So I just I need to find time. So to do that, okay, I'll isolate this. I'll divide heat by power. I know that my heat is 294,000. Okay, that's just what I calculated over here, so that's going to be 294,000. All right. Do I know my power? Yes, because it is provided in the problem that my power is 700 watts. Okay, that's also the reason why I use this formula here, is because we have information about power. Okay, so you would if we didn't know this relationship, we would be stuck at this point probably. Okay, so this formula here kind of helps us figure out what we need to find. So 700 times the missing time, I divide both sides by 700, I should get 420 seconds. Now take note of the unit. Okay, some people, because if you see 420, you get excited, you choose D immediately. But take note that this here is in seconds. The answer that deals with 420 is in minutes. So we have to change this to minutes. So if you convert seconds, okay, 1 minute is 60 seconds. Do the math, divide by 60. You should get 7 minutes as your answer. And so the answer to this question would be letter C. So it seems like a bunch of stuff involved. It's mainly just listing out what we have, okay, using a common formula that immediately comes to mind when we deal with specific heat capacity. But ultimately, it's kind of trying to know this formula over here, the relationship whenever you have power involved, okay, and then of course taking into account your units, okay, because like you have to know in this case the answer you will get will be in seconds, so you have to choose accordingly, convert if needed depending on the choices that you have.